Okay, year 11, we're going to look at some mixed trigonometry problems, and that will involve sine rule, cosine rule, and also we're going to have a look at some 3D questions as well. Now, use the sine rule to find a side if you're given one side and two angles. Use the sine rule to find an angle given two sides and one angle. So look, the sine rule, this is the way I remember it. It's two sides and two angles. If the question involves two sides and two angles, then use the sine rule. For the cosine rule, if the question uses three sides and one angle, use the cosine rule. Let's have a look at the first question. We're going to have to draw a diagram for this. The angle of elevation of a tower from a point A is 72 degrees. From point B, 50 metres further away from the tower than A, the angle of elevation is 47 degrees. Okay, we've got to find the exact length of AT, the distance from A to the top of the tower. So let's have a look. So we're going to start off with a diagram. Oops, bit of a kink there. Okay, so it says angle of elevation of a tower from a point A is 72 degrees. Angle of elevation is looking up. Okay. And from point B, 50 metres further away. So let's just get this out of the way for a minute. Call this point A just there. So from point B, 50 metres further away. So that'll do. I'll extend this triangle here. Okay, so this is 50 metres. And this is point B. The angle of elevation is 47 degrees. Okay. Now we're going to call the top of the tower T. There we go. And that will do, I think. And we've got the height of the tower H, because we need that as well, H. Okay. Now we're going to find the exact length of AT. Okay. So here's AT. Yep. And we're going to find its exact length. Now, how are we going to do that? Well, let's see if we can work out some angles here. Okay, so that's 72 degrees in there. That means this will be 28 degrees in here. Yep. Now that's 72 degrees there. Sorry, that's 18 degrees, not 28. That's 18 degrees. Now 72 degrees plus 108 degrees, so this will be 108 degrees there. Now 47 plus 108 is 155, so this will be 25 degrees in here. Okay, now we're going to use the sine rule here because we've got to find this side. We're given this side here and we've got two angles. So this angle is opposite this side. Yep. So we're going to start off with AT divided by sine 47 degrees is equal to, now the other side we know is 50. 50 divided by, and the opposite side to 50, the opposite angle to 50 is 25 degrees, so it'll be sine 25 degrees. Okay, so from that point on, if we multiply both sides by sine 47 times there, sine 47. Okay, so that cancels with that, and you're left with, now it says the exact, so the exact length means we don't evaluate it on the calculator. This is going to give you a whole lot of decimals. Okay, so that is your exact length of AT. All right, now part B says hence or otherwise. Hence or otherwise, so that's part A. Part B says hence or otherwise find the height h of the tower. Okay, now what do I know about the, I can, in the green triangle, we can use the sign SOHCAHTOA, okay, because it's a right angle triangle. So let me call this, I don't know, something like O. So in triangle A, T, O, what can I say? I can say that sine of 72 degrees equals the opposite side h divided by AT. Okay, we already know what AT is. So that means h will be AT times sine 72 degrees. And what's AT equal to? We worked it out in part A. It's 50 sine 47 degrees divided by sine 25 degrees multiplied by sine 72 degrees. So if we put that into the calculator, you should get 82.3 meters. Okay, 82, just fix that 2 up there. So 82.3 meters to 1 decimal place. All right. Okay, that's the first one. So we'll look at the next one. Okay, now ship sails from Sydney for 200 kilometres on a bearing of 040 degrees. Okay, so let's just get some more real estate here. We'll go to full screen mode for this one. Okay, so we've got to draw a picture here, don't we? So let's have a look. So if this is north, bearing 040 degrees would be out here somewhere. Yep. And let's call that 40 degrees. And that's for 200 kilometres. So 200 kilometres. Okay, and then they travel on a bearing of 157 degrees. Okay, so we could draw a second compass in. There we go. Now, bearing of 157 degrees will be down here somewhere. So 157 degrees. How many kilometres? 345 kilometres, so it's a bit longer than the other one. Okay, so this angle here, clockwise from north is there, is 157 degrees. And the distance travelled is 345 kilometres. How far from Sydney is a ship to the nearest kilometre? Okay, now Sydney is here, just here. The ship is here. Here's my ship. Okay, so we've got to work out this distance here. Right, let's call it x. Okay. Now, how do we work that out? Well, let's for starters, we can work out this angle in here. This angle here must be 23 degrees because 157 plus 23 is 180. Now remember alternate angles. Here's 40. So in here must be 40 degrees as well. Okay, that gives me a total angle of 63 degrees. All right, so I've got 3 sides and an angle. So I'm going to use the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Unknown side is x. So x squared is equal to 200 squared plus 345 squared minus 2 times 200 times 345 times cos A, which is 63 degrees. There we go. Now we're going to put that whole thing into our calculator. All right, that's going to give you, let's have a look. So 200 squared plus 345 squared minus 2 times 200 times 345 times cosine 63 close bracket equals. Okay, so that's going to give you 96374. 96374 dot 311, and it keeps going. Okay, then you're going to square root that and square root that. Now keep that whole number in your calculator. Just press square root and then press the answer button, ANS, equals. So you should get to the nearest kilometre 310. Right, to the nearest kilometre. Rightio, now part B. Part B is, what is the bearing of the ship from Sydney to the nearest degree? The ship from Sydney. Okay, so I'm just going to draw my ships here. There we go. Now the bearing's taken from Sydney, isn't it? Okay, so actually I don't need to draw my compass in there. Sydney is here. So we want this direction, okay? Which means I want this angle here, okay? If I can work out this angle here, theta, and add it to 40, I've got my answer. Okay, so we've got two sides. Yep, this side here, and I've worked out this side here. Actually, I've got three sides, and I've got two angles. Okay, so I'm going to use the sine rule. Okay, so I can go sine theta divided by 345 equals, now the only other angle that I know is 63. So I'm going to have to go sine 63 degrees divided by, okay, now I'm not going to put 310 in there. Okay, 310, how long is x? To the nearest kilometre is 310, but I'm actually going to recalculate that again. I'm going to put in 200 squared plus 345 squared minus 2 times 200 times 345 times cosine of 63. Okay, that's, and then I'll take the square root. So it's 310 on the bottom, 0.44, and it keeps going. Okay, now sine theta, it will be that. Now, if I multiply both sides by 345, I'm going to get sine theta equals 345 multiplied by sine 63 degrees divided by 310.44 dot, 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 dot. Okay, now we need to work out what the right-hand side of that equation is. Okay, now let's see how we're going to do that. So if I go, now the last thing I put into my calculator was a 310.44. That's still there. So I'm just going to go sine 63 divided by answer times by 345. Okay, and I should get 0.9901. Right, that keeps going. And then I'm going to go shift sine answer, close bracket, equals. Now it says to the nearest degree, so I've got theta is equal to 81.968 degrees. So theta is approximately 82 degrees. Okay, now I'm thinking that some of you might have trouble with the calculation of this. So I'm just going to show you how to do it on the calculator. Okay, so let's move this over here. So first thing I'm going to do is let's work out the we're going to work out the square root, well first of all 200 squared plus 345 squared minus 2 times 200 times 345 times cosine of 63, close bracket. Okay, now I'm going to square root that. Square root, press the answer key, equals. Okay, now I'm going to keep that in there. Now this is the part that I'm going to put into my calculator. Okay, so I'm going to go sine 63 divided by answer. Answer is the last calculation I did, okay, which is a 310.44, etc. Okay, and then I'm going to multiply that by 345. That gives me a 0.9901 and shift inverse sine answer equals, right? And then our nearest degree will be 82 degrees, okay? All right. Now, next question. Oh, no, that's not the answer, is it? Because theta is 82. But what did we want? We had to add 40 degrees to that. So the bearing, so we're going to write down the bearing will be the 82 degrees plus the 40 degrees, which is 122 degrees. Okay. All right. Next question. So we've got from point X, 25 meters due south of the base of a tower, the angle of elevation is 47 degrees. Now, this is a 3D picture. It's actually going to be easier if we draw the tower first. Here we go. We'll call this T. We've got to find the height of the tower, so there's H. Now, I'm going to draw south in an oblique angle. Okay? So I'm going to put south out here. And I'm going to put north out here. So this is the 3D diagram we're drawing. And it says point X, here it is, point X is due south 25 meters. Yep. So then I'll just complete this right angle triangle down here, because it says the angle of elevation is 47 degrees. Okay. Then it says point Y is due east. Okay. So east, it's going to be out here somewhere. Remember, north and east are at 90 degrees to each other. And that's, say, 15 meters. I guess that should be a little bit smaller then, shouldn't it? Try that again. Should be a little bit shorter. 15 meters. And calculate that distance there. And then draw my, should get rid of H here for a minute. And then complete the triangle. So there's another right angle triangle there. There's another right angle triangle. And, right, so that's my picture. Now, the question says find the height of the tower. Here's H. All right, so there's my diagram. Okay, So if now this will be 90 degrees here and here as well, won't it? Because south and east are at 90 degrees to each other. Now, if I wanted to work out what h is, how can I do that? Well, I know that cosine of 47 degrees, not cosine, sorry, tan. If I, okay, so now, so in this triangle here, this is the triangle I'm looking at, tan of 47 degrees is equal to opposite divided by adjacent. Okay, that's 25. So multiply both sides by 25, you're going to get 25, whoops, yeah, 25 tan 47 degrees. So that's what h is equal to. So put that into your calculator, 25 times tan 47, it gives you 26.8. H is 26.8 meters. So that's part A. Part B says work out the angle of elevation. So the angle of elevation, we've got to work out from Y. So Y is out here somewhere. So this is the angle we want here. So that means we're looking at this triangle. So draw the triangle here. Okay, T is at the top. Y is over here. We've got to work out what theta is. Okay, now I know that this is 15 meters. I've already worked out what h is, so I know what that h is. So I can go tan theta is equal to h on 15. Okay, so that gives me that h is equal to, actually no, we want theta, so hang on. I'm going to work out, when I do this, I'm going to use the exact value for h. So I'm not going to use 26.8, I'm going to put in 25 tan 47. I'll get a more accurate answer that way. Divided by 15. So let's work that out. So that's going to give you tan theta. So 25 times tan 47 equals, divide by 15 equals. So it's going to give you 1.78. 7 ... Now, shift to tan, or shift inverse, we want to get the inverse tan, don't we? So the next step is theta will be the inverse tan of that. So that's going to give you, now, I guess degrees of minutes. It's going to give you 60.77 degrees, ... keeps going, to the nearest minute. Doesn't say what to do, so we'll just put both answers. So to the nearest minute, that'll be 60 degrees, 46 minutes. Okay, so that's that one done. All right, last question. We've got a cone, has a base diameter. So let's have a look at the cone here. So, for the cone, let's just change that. So we've got the cone. So draw the base of the cone. And then, there we go. Now the diameter of the cone, which is this distance here, all the way across, is 18 centimeters. So 18 all the way across. The slant height is 15 centimeters. We've got to find the vertical angle. Now the vertical angle is this angle here. So what we're going to do first is we're going to draw the height of the cone which goes to the center of the circle there. That's the right angle triangle. And that means this distance here is going to be 9. Okay, and now we're going to work out what this angle is here and then double it to get the vertical angle. So what we can see here is that sine theta is equal to the opposite side, 9 divided by 15. So that's going to give you theta is the inverse sine of 9 on 15. Let's just fix it up. On 15. So let's work that out. So shift sine 9 on 15. It's going to give you 36.869. Now, the vertical angle will be 2 theta. So the vertical angle equals 2 theta. So we're just going to times our answer by 2, times by 2. So that's 73.73 degrees. Now it says, does it say to the nearest minute? No, but we'll do it to the nearest minute. So press degrees, minutes, seconds. So you're going to get 73 degrees, 44 minutes. Okay, and that's it.